Okay, for our first test, let's try hooking up a DHT sensor and an LCD screen. The DHT sensor will be connected to our transceiver Arduino and will send temperature and humidity readings from the MCP2515 to the other MCP2515 across our mock CAN bus. The receiver Arduino will then display that data on the LCD screen. I also included a button connected to the receiver Arduino on pin 7, but you can skip this step if you don't have one. Now that we've gone through that build, let's start coding in the Arduino IDE. You can access both of these files from the GitHub link in the description. Starting with our receiver code, the first thing we need to do is include our three libraries, SPI, MCP2515, and the liquid crystal. Next, we're going to declare several constants, as these are the pins we're going to use for the LCD screen. Next, the liquid crystal call is to define where to run the LCD screen on the pins we just named. We're going to declare pin 1 as an input, so I named it LED switch here. Next, we tell the MCP2515 what pin we are using as an SPI CS, which the default is 10. Going into our setup, we're starting our LCD with 16 by 2 dimensions, setting our cursor to the 00 position, and at the start of our project, it prints out a message to check that the screen is running. From here, we'll call LCD clear to clear our screen. Whenever you're using LCD screens, you want to call this before you try to print a second object, or it'll just copy over it and make a mess. We're going to begin our SPI communication by calling the SPI begin, and we're going to set it to a baud rate of 9600. We want to reset our MCP2515 at the start of our code just in case there's anything lingering. So we're going to set our bit rate at the CAN to 500 kilobytes per second. And remember the crystal speed that I told you to check out on your version of the chip? This is where it comes in. Since mine is at 8 megahertz, we've set it to MCP_8 MHz here. If yours is at 16, you're going to change this 8 to a 16 to match that. And then you're going to set it into normal mode. Going into our loop, here's where we start programming the pieces of our message in CAN format. In our first if statement, if we have the framework for sending a message laid out, in the first part, we send an ID number of our choosing. In our Arduino version of a CAN protocol, we would have the Arduino look for this ID, and if detected, do something with it. Next is where we're declaring our data length, and we have that set to 8, so you'll see this is an index of 8 items. If we had some data to pass, this is where we would put it in. So we have like a random 9 and a 4 in here, but nothing's being done with that data. This is just where you would put it in. At the end of that, we tell the MCP2515 to go ahead and send this message. And then going down into our if statement, this is going to be where we have our main code being used by this Arduino. The MCP2515 is constantly listening for a message and checking that message for errors. If we get a message and there is no error, we next check the CAN ID. If we specifically get the ID 0x036, we're going to take the data from index 0 and we're going to store it as X. If you look up here, this would be this line of data. We're going to take the index 1, which is this line of data, and we're going to store it as Y. Then below that, we're going to print to our LCD. We're going to set our cursor to 0, we're going to print the word humidity, and then we're going to print X because that's our humidity reading. Then we're going to do it again for temperature. And then we're going to clear our LCD screen after a delay. If we were to get our alternative ID here, this 024, we're going to set our cursor, but it's going to print the message button pressed. And then it's going to wait just long enough for us to be able to see it, and then it's going to clear the LCD. Now we're going to move over to our transmitter code. Again, we're going to call our libraries at the top. Then we're going to go in and we're going to define the things that we need for the DHT. Here's where I've set up the variable 7 to go along with a button should you set that up. But if you don't have one, you can omit that part. And then I have an LED connected as well in my setup for feedback. Then we're going to again declare MCP2515. We're going to call our DHT and have it set up. And then going into our setup, we're going to start serial if it isn't already. We're going to declare the beginning of our DHT readings. We're going to reset this MCP chip Do the same kind of declarations, again, checking for that crystal time and start at a normal mode. And then I have the button from 7 above checking as an input, and then we have my LED as an output, should you include that part. Coming down here into our loop, if that button is pressed, it's going to be reading on the My Button thing. It's going to change that variable for us. If we receive a message back from the other Arduino, our first receiving Arduino, if it sends us any messages, we're going to have this one just print to serial got it. And this makes it so you don't have to set up a second LCD screen. You can just leave it connected to your computer and check this part. Whenever my button is detected as printing as high, it's going to set it to this 024 as the ID. And then these parts again aren't used. It's just sending this ID with these parts attached, and then at the end it calls to send it. And this is back on our other screen um, where our other Arduino would print if it got this secondary message. Otherwise, if the button is not pressed, it's going to continuously read from the DHT, save that to the variable H. It'll read the temperature from the DHT and save it to the variable T. And here's where it passes this ID, and it passes, and here's where we see some useful passing of data. Index 0 is going to be set to that H variable, index 1 will be set to this T variable, and when the message is sent, our receiver will pick up those messages and it's going to print to the screen as X and Y. Okay, so there we go. We've sent our first um, message back and forth across our CAN line.